It's pronounced Juan. All right, so guys, that is Juan. Okay. How many of you think he threw it the furthest at 57 yards? 1.
Oh, me.
2. Okay, what about Amelia? 179 feet. Just one? Okay, Ken, 1/30th of a mile.
Like me. 30?
1/30th. So that's like if you split a mile up into 30 pieces, he threw it one of those pieces. That's what 1/30th means.
Oh, I thought it said 13.
And then, all right, Geraldine, let it rip for 2,100 inches. Anybody pick Geraldine? Wait, I thought you just picked. Oh, you okay? All right. So
only 7 people answered.
I guess the rest of you didn't vote. All right. So to do this, let me remind you of some of the questions I've gotten. Okay. Especially Eliza has been the main one asking. Wait, how many feet are in a mile? And I know some others asked that. Okay. Please don't miss this. This is the meat of this problem. Okay. How many feet are in a mile? Or how many feet are in a yard? Did anybody have to ask themselves how many inches are in a foot?
No.
You should have. You should have. Okay. That is what our lesson has to do with today. Okay, Mackenzie, you had a question?
Did somebody else do it? Because I know one person picked on, but I didn't. I went like that.
I picked laundry vote.
All right, hang on. This part was just for fun to see what you thought when you read it. Jonathan, did you have a question or a comment?
No.
All right, so Eliza and anybody else who was thinking, I need to know how many feet this is. What she is doing, and what I think many of you are thinking, is the only way to do this is if they're all in the same units. Okay, Colin, I heard him say, I know yards from football. I bet that's true. But here's the thing. How do you go from 1/30th of a mile to yards or feet? So, Daniel, can you help us get started?
I would have gotten it correct, but I thought it was 113.
Oh.
Yeah.
Well, that's not. I'm just. How do we get started? That's what I'm looking for here.
You figure out how many feet are in a mile or yards are in a mile.
Okay. All right. Well, let's. So, how many yards are in a mile? How many feet are in a mile? Do you see what he's doing? Yeah. So, do you want to convert everything to miles, or do you think it would be easier to use a smaller unit?
Smaller.
You want to use a smaller? Okay.
Yeah.
All right. So, Luke, do you know how to get from yards to feet?
Yards to feet.
So, 1 yard.
Multiply by 2.
Is it good? 1 yard, for each yard, that's 3 feet. So if there's 3 feet in each of these, I'm going to multiply by 3. We're going to multiply by 3. Now, write this down and pay attention to why I'm putting the units where I am. I'm going to do my dot there, or do you guys want me to do the X?
3 dot.
Dot, okay, 3 feet. Now look, I'm going to make it a fraction. Now here's what I want you to see. If you had yard divided by yard, we call that canceling. That's going to go away. So the yards have gone away, and then I'm left with feet, and 57 times 3 is 171 feet. Okay, now how is that helpful? Well, it's helpful because now Emilia has 179 feet and Juan has 171 feet. So we automatically can eliminate Juan. He didn't throw it as far as Amelia. Okay? So, do you see what we're trying to do here? We're trying to get everybody into feet. Maybe you wanted to get everybody in yards, and that would be okay. I think feet's going to be the easiest one here because it's kind of like meeting in the middle. Question?
Can I erase what I did? Because I don't think it was right.
Sure. That's fine. Jonathan?
Could you do it in inches?
You could. You could actually do it in any one of the 4. But I think, you see, I gave you 4 different units on purpose. I wanted you to have to battle with the idea that just because this number, 2,100, is so big, that doesn't mean anything if the units are really small. Let me give you a monetary example, okay? Suppose someone comes up to you and says, hey, I've got 271 million pennies here. And the other person says, well, I've got 1,400 $10 bills.
Whoa.
Just because that number's smaller, you can't just base the amount on the number. You have to know the units, correct?
Yeah.
So, the units are what matter here if we're going to figure out which one is actually farther. Yes, sir?
When I was in kindergarten, someone for my birthday said I could either have a jar of 100 pennies or have a expensive mystery present. And guess which one I picked?
The pennies.
Yeah.
Okay.
So I ended up getting $1 instead.
Oh, man. All right, so you know from experience. All right, so, front row, let's stay focused here. I'm going to skip this one just for a minute because it involves the 5,280. Geraldine let it rip for 2,100 inches. So 2,100 inches. Now look. Shh. What do I need to convert that to if you look at my first two statements? I want feet. That smells. I want feet. I want to know how many feet this is. So, pay attention, write it down. I'm going to multiply by something. Now, who can tell me what the relationship is between feet and inches?
Can I go potty?
Can I get up through this problem first? Who can tell me, raise your hand, don't just blurt it out. Who can tell me what the relationship is between feet and inches? Down your left?
They are units.
Who can tell me what the relationship is? Colin?
You can measure with perimeter with them.
Okay, I'm looking for the connection, or like,
They
what's
both
the
have
difference
the
in the
ion.
units? Mackenzie?
12 inches going a foot.
That's it. There are 12 inches in each foot. Now watch how easy this is. Jackson, watch and write down, not fan that, okay? Let's do what we're supposed to do. There are 12 inches in 1 foot. Now look, I want my units in feet. So look, I'm going to put feet on top. Don't get too comfortable. In 1 foot, 1 foot, there are how many? Mackenzie said 12 inches. Now, why did I do it in that order? Because I want the feet.
Ooh, 1 feet, no, it's 1
What's
foot.
going to happen as a result of that is the inches will cancel. Now, look at the numbers. Where did I get the numbers? She told me that 1 foot was equal to 12 inches. She's right. Now, what does this mean to do? Since the 12 is on the bottom, I'm going to do 2,100 divided by 12. And I'm going to get, well, somebody asked, can I use a calculator here? And I said, yes, you can. So 2,100 divided by 12, 175, what?
Inches. Feet.
You see, we got the inches to cancel, right, Luke? So 175 feet. Now, look how close that was to all the other ones.
Oh, wow.
171, 179, 175. They're actually really close to each other, aren't they? The last one we have to do is Ken. This isn't Barbie Ken, I don't think. But you go by Ken. Okay. Okay, guys. Why does that happen? How do we find? You guys are incapable of. Stop. 1/30 of a mile. How do you find 1/30 of something? What's a simple way to do that?
You divide it by.
Do what?
Divide it by 30.
Is that what you said? Yes. You both agree. Divide by 30. So let's do that. 1 mile, though, you might not know this, and I had to tell some people, and that's okay. That's 5,280 feet. We're going to divide it by 30. Now, look at what I'm doing here. I'm using a fraction to show what operation?
Division.
Yes. Please get into that habit.
I said that.
But when we divide that by 30, we get 176.
So 1,000,000
Amelia flew with the bodies.
Okay.
Laura.
Guys.
Your name, Mister.
176 feet. All right, Mackenzie, you had your hand up first.
That's what I did, but I got 179.
All right, let's type it in here real quick, guys. Shh, we don't use these a lot. Question?
I thought it was because I did.
You were wrong.
Divided by 528.
You did what divided by 528?
10. Because I thought it said
Oh, you thought the same thing as Daniel left. I see. Okay. Yes. All right, so let's recap what we just did. Do you see how close all of the throws were?
Yeah.
Yes.
They were all in the
They were all in the 170s. They're all quite close. Okay? Shh. I want everybody to hear it. So, what did we have to do to actually answer it? We had to get them all into the same units. Okay? You're going to have a hard time comparing something that's in pounds, to something in kilograms, to something in ounces, to something in stones, which is a way that another country measures weight. Stones.
That's a bit odd.
So, the key, what I'm trying to get you to see here is that you've got to be able to change or convert. Change it from one unit to the other based on a numerical relationship. All right, so let's get our notebooks out. Let's get our notebooks out, please. I did. I saw yours. So, draw a spinner with 4 sectors labeled A, B, C, D. Make the sizes such that with one spin, the probability of A is 1/2. Well, I'm going to go ahead and separate it into halves, and I'm going to put A on 1/2. The probability of outcome B is 1/4. And then outcomes C and D are equally likely. How do we do this? Anna.
take the bottom part below
The empty part?
split it in half.
All right, if I split it in half, then these two pieces are the same size. And if they're the same size, then it makes the probability of spinning them what? The same or equal. Okay, so we'll put C and D here. Yes. Yes. All right, so seats on the floor, please. Daniel, thank you. All right. Mackenzie, did that answer your question? Probability of A was 1/2, so that has to take up half the circle. B is 1/4, so that has to take up 1/4 of the circle. C and D have to be equal pieces of what is left. Jackson. Yeah. All right. So, the next part, 73, was yesterday's work. We're going to talk about lesson 74 when Jackson gets back. So, let's take some notes, guys. 74.
That was cool.
Guys, this is supposed to be a 5th grade classroom, not a preschool. Let's act the way you're supposed to, okay? Unit conversions of length. Okay, now you already did that. You watched me do it on the warm-up. Let's go back to some of the... Colin. Units we should know. Okay? And if you don't know them, you need to spend some time reviewing them and memorizing them. Question. Whenever the next person gets back. Somebody's in front of you. James. Okay. Yes. It's right there. Okay. 12 inches is a foot. 3 feet is a yard. 5,280 feet is a mile. Now this is probably one you don't use a lot. Okay? 1,760 yards is 1 mile. That's an actual mile. they run something different in the Olympics. It's called the metric mile. Okay, it's really close. 1,600 meters, though, okay? And then this was a quiz that I remember caused a lot of you a lot of trouble. Parts of a meter. Now let's think about a meter for a second. You've probably seen a meter stick before, okay? But let's draw a picture of a meter stick that helps us understand the parts of it. Colin, stay after class, please. So let's draw one long line. That's going to be our meter, okay? We'll just put an end point there, okay? So 1 meter. So if I squeeze this into 100 parts, 1 centimeter, we have to understand, because that's a centimeter, there are 100 centimeters in 1 meter, okay? There are 100 centimeters in 1 meter. So what do I have to do to a meter to get to a centimeter? Or divide by 100, right? I divide it into 100 pieces. Or said another way, 1 meter is equal to 100 centimeters. You actually multiply the number of meters times 100 to get the number of centimeters. That's what is meant by this statement. 100 centimeters in each meter. Each is a word that's going to tell us, in this case, to multiply. Okay? So, for example, 74.1. Suppose I had 2.56 meters. And I want to know, meters, how many centimeters that is. Because you know, hang on, Julian. Because you know that each meter has how many?
1.
Each meter has how many centimeters? 100. So, how many meters do you have? 2 holes and then 0.56 of another. So in the first meter, there's how many centimeters?
200.
In the first meter,
200. 100.
there's 100. And then the second meter, another 100, which is why you guys are telling me 200. But let's split this number up, okay? 1 meter, 0.56 meters, okay? So there's how many centimeters in this one? 100. There's how many centimeters in this one?
100.
Another 100. What about this one? 56. Now, real quick, let me give you a quick reminder. How do you say this number 0.56 mathematically? Hang on. Jonathan?
Can I say the whole number?
What do you mean?
2 and 50.
56. What? It's hundreds. Remember the second decimal place? You're so close.
I thought it was the first one.
The first decimal place is tenths. The second one is hundreds. So I like what you did there. 2 and 56 hundredths. Well, wait a minute. Isn't a centimeter 100th of a meter? So Julian and everybody else who said 56, you guys are correct. That would be 256 centimeters. But what if we did it the way we did the warm-up? What I did with the warm-up, I used a conversion factor. Daniel, do you have a question?
Were we supposed to draw?
No, I didn't want you to do that. That would have taken a whole lot of time. And it seems you already did it. So, here's what we're going to do. Okay? We're going to use a conversion factor. Okay? And it's going to be, I'm going to call it a fancy or a chameleon 1. I don't know if you guys will spell chameleon right now, but we're just going to call it a fancy 1. Okay?
CHAMELON.
You missed the E before the O. Chameleon. All right, so here's what we're going to do. We're going to take 2.56 meters and we're going to multiply by something in parentheses that is equal to a fancy 1. Okay? Fancy as it could do a little trick. What am I looking for in my answer?
Centimeters.
So that's what goes on top. What do I want to cancel?
The millimeters.
No, the meters.
The meters.
The meters. Now we simply go back. How many centimeters are in a meter? How many meters are in a centimeter? All right, that's the one we want to use. 100 centimeters in 1 meter. Now look at what I have here in parentheses. Isn't the top equal to the bottom?
No. Yeah.
It is. And when you divide something by itself, what is the answer?
1.
It's what?
1.
It's what?
1.
Anybody else?
1.
It's 1.
It's 2.
Okay, don't try to trick anybody. So this part, that is what we are using as my fancy 1, but hopefully you're not going to miss out on what just happened. So this part is all equal to 1, so I'm not changing any values. I'm not changing the distance that anybody threw it. All I'm doing is converting the units. So what is 2.56 times 100?
256.
It's 256, and let's pay attention to the units. The meters will do what? There's meters on top. There's meters on bottom. They're going to cancel out. So I get 256 of the units that did not cancel out. Now, that might be a much harder problem than you guys see on the homework. I don't know. But maybe we should try one of the problems from the practice set and just see if it's harder or easier. Question?
Can we put Camille in one?
Sure. Yes, Jonathan.
Can you turn back to the book? I was making things.
You got the book, buddy.
That thing right there.
This thing? You got your book, right? All right, so I think Jonathan's onto something. It wouldn't be a bad idea. So how many yards? So this question is going to mingle the units, okay? How many yards are in a quarter mile? Okay. Is it a funny question? Yeah, I know. Got it? All right. You still see it. All right. So this is straight from the practice set. Got it. How many yards are in a quarter mile? So let's think about something. In our warm-up, we were able to say, I want to change everything over to feet. But what they want you to put your answer in is yards. So here's what we're going to do. We're going to write 1/4 of a mile. Okay, then we're going to multiply it by something or some things.
Miles.
So, stay after class, you two, both of you. Okay. 1/4 mile. How do I get to yards? Is there a middle unit that I have to go through? So if you look back at the table that Jonathan was intelligently copying, in order to go from miles to yards, we have to think about feet. Or maybe you could use this one. I don't know if you guys memorize that one. Or maybe that's just me. I don't memorize that one. I don't know that one by heart. Maybe we should. Maybe we should. So here's the one. Hang on just a second. I'll let you guys talk. This is the one we're going to use because it's the one that relates the two units.
17 football fields.
And then some, right? All right, so Julian, you were going to tell us how to proceed. So here's what we know. I'm just going to copy the information over from the table. 1 mile equals 1,760 yards. Okay, so this is from the table. How do we use it? Is that what you were going to tell me?
So you divide it by 3.
All right, so when you use that table from page 382, those are the numbers that are really going to be used. If you look at what my fancy one, or as Mackenzie likes, my chameleon one earlier, you'll notice that I have to use something like that to help me here. But it's really equal to 1. 1 mile is equal to 1,760 yards. If I want to get rid of miles, because I want yards, then I have to have yards on top and miles on the bottom, okay? Hang on to your pencil, okay? What numbers go in here? Well, the table on page 382 tells you what to put. You just have to read it. In 1 mile, there are 1,760. There are 1,760 yards. So what is it that I have to cancel? Well, I have mile here, and I have mile here. What is it that I have to multiply? 1/4 and 1,760. So how do you do that? How do you find 1/4 times 1760? Do we know how to multiply a fraction and a whole number?
Yes.
How do you do it, Daniel F.?
If it's just one out of something, the bottom number you multiply the top.
No.
I mean, no, not the top. The main number. The 1760.
All right. So when you
4 times that.
let me ask you a different question. Let's see if that goes along with what you said. When you take 1/4 of something, that's the same as what? Dividing by what?
4.
Dividing by 4 is the same as multiplying by 1/4. Isn't it? Mackenzie, question?
Two things. Do you want us to draw the table in our notebook when we...
You don't have to. No, you don't. No, you don't have to. You can just use your book.
Okay.
Second thing?
And would you times 1,760 times 4?
No. You see, if we're multiplying by a number that's smaller than 1, aka 1/4 in this case, what we're saying, as Colin mentioned, is that to take 1/4 of something is to divide it by 4. And so we're going to get 440 yards. 440 yards. Okay? So all of the problems in 74, that practice set, they're gonna look like that. That's, if you look at how they did that one, well, we didn't do that one. I just did practice set A for you. Okay? And then let's make sure I get through the other lesson. I do want to get through 75. What is going on back here, buddy? Can you sit still? Hey, come on, this is my stuff. I got to try and keep it organized or I might lose your tests.
Yay! Yay! Keep on making messes. Keep
All right.
making messes. Keep
That's you're really not going to be happy about that if I lose your corrected test.
Oh.
Okay, so that wouldn't be good. Shh. Yes.
Did you after that 440?
Yards. YDS. All right, lesson 75. We're going to convert improper fractions. I think you might already know how to do this. Do you guys remember the Delta Math tape diagrams? And they look kind of like this. So, let me see if I can do these all the same. And let's make this 1/3. Okay.
3 and 1/3.
So, before we get there, right, you had to add up all these thirds. So what was the improper fraction that this diagram would go with?
10 thirds.
All right, you get 10 because you just count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 thirds. Right, that's 1/3 plus a third plus a third plus a third. There are 10 total. But, Colin, you said you could already look at it and tell me what the mixed number was. What'd you say it was?
3 and 1/3.
All right, how did you get that?
Because I added them all up. Well, didn't add them up. I put them in sections of 3.
Sections of 3. How'd you know to do 3?
Because the numerator and denominator on that.
How many thirds make a whole?
3.
Don't miss that. That sounds like a simple question. I don't know if many of you heard it. How many thirds make a whole? 3. 3. So if I group them this way, it's really easy to see why Colin said 3 wholes and 1/3 remaining. Now, without a picture, so we'll call this 75.1. Without a picture, let's think about how can we do that? Let's look at 29/4. Okay, so
7.
hang on, whoa, chill. I feel good about what you got. Okay, let's make sure everybody else has a chance.
I know that one because of football. 28, 4 touchdowns.
I think you can relate everything to football. It sounds like so 29/4. Could you do this with drawing? Yes. Would it take a while? Uh-huh. So what I want you to think about, do you have a question, Anna? Okay, go ahead. What I want you to think about is, what's the closest multiple of 4? And if you don't know your multiplication facts, it's going to take you longer. What's the closest multiple to 29? Jonathan?
28.
28, okay. So here's what I'm going to do. I'm going to change this. You're not going to have to do this every time, but this is what I'm going to change it to. 28/4. And then how many are left that we didn't get to, Jonathan? 1. All right, so stop right there. Take a time out. 28/4. Does everybody understand why Jonathan said 28? That's the next largest multiple. 7 times 4 is 28. Great. Well, what do we need to change that to since
7.
it's the whole number part, isn't it?
7.
And then I can't change that to a whole number. So my 1/4 is what is left over. Now, did anybody else have their hand raised just a second ago?
Well, I would have, but
Okay. So 29/4, that's an improper fraction. We change that to 7 1/4. Is there another way to get to this answer? Well, if this is a fraction, it's communicating what operation?
division.
Yeah, division. So we're going to say 29 divided by 4 like this, and we're going to see what happens because, oh yeah, this was one of the last questions on that last test. Do you have a question? Yes. So 4 won't go into 29. I'm sorry, 2, but it will go into 29 7 whole times, right? 7 times 4 is 28. We're going to subtract and see what's left over. Ken, what's left over? You said you go by Ken sometimes. 29 minus 28? 1. All right. Let's stop right there. It equals 1. Can you put 4 into 1? No. So what we've been doing is saying 7 remainder 1, but the goal here is to be able to rewrite that as a mixed number. So we take our remainder and we do what with it? We take our remainder and we do what with it? It becomes the numerator, and the denominator stays the same. You should get the same answer. Now look, I've given you 2 ways to think about it. You don't have to do it the same way as your neighbor. Okay? But you do have to do it one way or the other. Okay? One last thing to consider. 29 divided by 4. If I type this in, what do you think my calculator is going to say?
Can I answer question real quick?
Yeah.
7 1/4.
7 1/4. Do you think my calculator is going to give me the fraction?
It's gonna,
Yeah.
Mackenzie?
it's gonna do 7.4.
A 7.4? Let's see what happens. Oh, why did it give me 7.25? Jocelyn? That's what's equal to 1/4, isn't it? 0.25. Mackenzie?
1/4 is a quarter, and then 25 is a quarter of a dollar.
25 cents. That's right. 25%. We're going to do that too. All right, so I have a couple for you to try here, okay? And I want you to draw a picture for all 3 of these, okay? Okay, so those are the three I want you to do. Now you notice those are larger numbers, but I figure if I give you harder problems in class, then the homework will be easier, okay? So right of 7, that's kind of tough, right? I saw what Eliza wrote, 100 divided by 7, right? So what's 7 times 12? Let's get really close.
7 times 12, 77.
84.
Come on!
We get 91, 13, 98, 14. So this one's going to be 14 and 2/7. This one's going to be 6 and 4/9. This one's going to be 4 and 2/21.